Welcome class, welcome to Doppler Effect. So we have question 6. This is a grade 12 Doppler Effect problem. As you can see that you have 6.1 up to 6.5. So you can read the questions as we go up and down and then answer the question that follows. So we have the question, which is state Doppler effects in words, and then they want it in words. You can derive that from the equation, but in this case let's do it in words. The apparent change in frequency, so frequency can also be considered as a pitch of the sound detected by a listener. Listener is the observer, because the sound source, so the difference between the sound source and the listener have different velocities relative to the medium of sound propagation. So sound propagation means transmission of anything, like the how sound travels. So that's what propagation means. So we're going to answer question 6.2. So 6.2, we need to first find the equation of the wavelength, as you can read on the question. But remember to pause the question as you answer. So here we have wavelength is equals to, as you can see, that's 340, that's the V. And then we have the speed there, which is 300. That's frequency, which is 300. So the wavelength there will be 1.13 m, which is beta. And then we move on to question 6.3. So 6.3, it actually requires us to give reasons. What are the reasons for the that is the reason why we need to apply Doppler effect medication. So that is to monitor heartbeat of a fetus and also to measure the rate of blood flow. So those are the medical ones. There could be other ones, but those are the most popular ones. And then we have to go to question 6.4.1. So 6.4.1, it says calculate the wavelength of the sound as perceived or heard by observer B. So observer B, as the car travels towards the observer, then you expect an increase. So you can expect an increase there of the frequency. So we write the equation. Remember to write the basic equation as in the formula sheet, so that you can be allocated the 1 mark. It's the one subject that only get marks for equation. So as it approaches the observer, we have to calibrate. So velocity of listener is 0, and VL there, or VS, is 0. So those are two situations. You never have both moving or both, so one of them should be 0 speed. You should have a 0 speed. So there we go, that VL is 0, so we don't have VL, then we have VL minus. So remember that it's moving towards, why is it minus? Because it's minus so that we can create a ratio greater than 1, so that the ratio greater than 1 is going to subtract, is going to reduce the frequency of source. So you can see that from that equation we have the wavelength is equals to V over frequency. So let us calculate the frequency of the listener first. So the V there given is 340, and then that will be 340 minus, that will be 30 meter per second. So it's all speed there, that is it. So we have 30 meter per second for the car. That is our 30 meter per second. So the frequency of the source is 300, and then that will give us, so we have to simplify. simplification there will mean that we have 340 over 300, and that will be divisible by 310. So 340 minus that. So we have to calculate 340 by 300. That is that, and when we divide everything, we get 329. So our FL frequency of listener will be 329 point. That is, if you multiply 340 by 300 divided by 310, you get 329.0. So getting back there, we have the velocity then, and then actually we have, that is wavelength, which is 340 over 329.03. Alright, so remember that it's the wavelength, so I have to rewrite everything so don't make a mistake. So it's the wavelength, once again, that's the equation there. So 340 that's the speed of sound in the air, that is 329.03. That is the speed of sound over the frequency. So dividing that again, we get 1.33. So that is our answer. Alright, so that is as observer on the other side. Observation. So I think that is observer B based on the question. So running off to 2 decimal places, that is 1 point. So wavelength is unit is meter. That is observer B. So now we have to calculate 6.4.2 observer A. Observer A, VL is 0, it's not moving, and then the car is moving. And then what do you expect the frequency to be? We take the general equation there, and then once again we have to write the full equation, but we know our target is wavelength over wavelength will be constant speed of sound in air divided by frequency. So our frequency there will be frequency of listener there would be V plus minus VL over V plus minus VS, and that. So we're going to have standard equation again, and then from there we calibrate. So remember that it has to experience a decrease. So we're going to make our numerator smaller and our denominator bigger, so that we have a ratio less than 1. And then from there we can see that VS is moving away. So you must always notice that, is it moving away or towards? So moving away, the frequency will decrease, obvious. And then we have 340 there over 340, and then plus 30, the speed of the source, and then that multiplied by the frequency of the source, which is 300. So we get the 300 once again there, and then that's frequency of the source. That's the source is the car. Then from there we have our frequency of the listener in a final answer. So that is, we simplify once again. So you can see that it's 340 times 300 all over 340 plus 30 is going to be 370. So that is it. And our answer, we can go to calculations once again in the computer, calculate that, divide by 370. So we found that is it's 275.68 as our final answer. So wavelength again will be V over frequency, so that will be, we have our 340 there as our V, so giving us our 340, and then divide by our frequency as observed by A, and then that is our final answer there, wavelength, and that gives us 1,23 if you use your calculations, and that's frequency of the listener for A as it observed. So that is our final So that is it. Now we go on to the next question. The next question, 6.5. It says the police car, as you can read, the police car stops with the siren. Observer V moves away. So observer velocity of source is 0 in this case, and then you have frequency of the listener as the observer moves away. So that will mean that there will be a decrease in frequency. So going to our answer, we're going to choose greater than, less than, no, equal, no, less than, correct. So our answer will be less than. So we're done. Now this is homework. I'll help you read the homework straight. So the siren of the stationary car moves, and then towards the listener. So we have the graph there with the information. And then I hope you do this activity and then submit. Otherwise, don't forget to subscribe. Enjoy the rest. Yeah, any question, let me know in the comments.